Kate, what is January?
44. 48.
Oh, wait, 44?
Yeah.
All right, February's 48.
Yep.
Okay.
57.
Oh, that's warm.
65. 72. 78. 82. 81. 76. 65.
Well, I'm sorry, I skipped one.
Those are like good temperatures though. It's not
No,
too
remember
hot.
it's the average from the day and the night.
Yeah.
So,
That's the
okay,
average.
it's
I was
usually
like,
like
wow.
105.
That's
Okay,
like 'cause in June
10?
Was that September?
October.
October.
65. 56. 48.
It's really, I don't, that never seem that warm, that cool down there. It's always hot. Okay, I think the temperature today was in the 70s. Okay, so now I'm going to go over, when I get your project, if the window, when you screenshotted it, so you may need to resend it, but I only want 1 year. So you'll have 0 to 12. I'm just going to step by 1. I want to go up to like 100 degrees here. Kind of depends on your city. All right, so there's my data. All right, now on the sheet, which I don't have in front of me and I'm not going to pull up, but I'll write it as I would in my sheet. The first thing is vertical translation. And so for vertical translation, I'm going to get, first thing, is it amplitude or vertical translation? Vertical amplitude. All right, amplitude is, okay, makes a little sense to find the vertical translation, the second one first, and then go back. I'm going to find the vertical translation. It's the average of the highs and the lows. What was the low? 40 something?
44.
All right, 44, and the high was 81, I think?
82.
82 divided by 2. So the average annual temperature there is like 63 degrees. All right, and what was the high? Okay, so that's what you would write in the vertical translation thing. You would show me the math before you put in 63. All right, so in my data, if I start to write my equation, in my y equals, so I have y equals 63, and it looks good. It cuts through right as the average temperature.
Yeah.
Okay, so now let's find the amplitude. So the highest temperature was 82. So for the A part, the amplitude, I would say 82 minus 63.
Can you say vertical shift instead of vertical translation?
Yes, the same thing. Okay, so it looks like 19 degrees is the amplitude. You could also have said 63 minus 44. It should be the same distance from the high to the low, from the middle. All right, so show me your work, like a high minus the vertical translation will give you your amplitude. And you could just crank these out and do them every time. So I'm going to put in 19. I think all of us decided to go minus cosine. So I'm going to go minus 19 cosine x. Okay, so now I feel good about the amplitude and vertical translation. Obviously, the period's way off. Okay, so for period, what I would want you to show me on your thing, don't write 12. If you write 12 by period without showing me your work, I'll count off. Okay, I know the period's 12, but you can't put 12 in your equation. Your whole purpose of doing this is to make your equation come out to where it has a period of 12 and all the other things. So show me how you do it. You can do this every time. For the period, you can say 2 pi over b and force it to be 12. I think all of y'all have done that. Hopefully you write it in or type it in your document. And then you cross multiply, and when you're all said and done with that, you all actually should get a period in this situation of pi over 6. I'm sorry, you should get a number pi over 6, which forces the period to be 12. So it'll morph into a better thing now. But you show your work. And I'm doing it really fast, so you can let me know if you have questions. Parentheses, pi over 6. And now I feel a whole lot better about it. But now I need what to add or subtract. And this is where people are just like punching in things and moving things left and right. And that's not okay, okay? You don't want to be laying on a table going through some test at a hospital and them, I don't know if you've ever had one. I've had too many given my cancer, but they put the machine right where it needs to be. In fact, I have permanent dots on my legs and my torso I've had a couple of friends that had radiation and they marked them with a Sharpie or some like super permanent pen that would last them a few weeks of the radiation. And so they're doing it to me. I'm laying on the table and the girl's like, I didn't have a tattoo yet, I have one. But anyway, she's like got something that she's about to mark on me with once they've decided where everything should be for me, okay? But if they're guessing and checking instead of doing the math, it's not gonna turn out really well. You don't want to radiate the wrong part of your body. So, I mean, it was like it was a target like we do in math. I could lay on the table and actually see the target from the machine. But to place the machine correctly every time, they bolt me onto a table they make a plastic mold of your body. Or wherever my sister had radiation on her head. Thank God I didn't have a plastic thing bolted on my head like she did because I'm claustrophobic. But they put this plastic mold on you and they actually bolt you into a table to where you can't move because it has to be so precise. But anyway, these little dots on me showed them right where to lay everything before they bolted it. And I'm like, oh, are those like, how do these Sharpies work? Like, how come it stays for a few weeks like I've seen on my friends? And she goes, oh, no ma'am, I'm tattooing you. I'm like, that's a tattoo, can you make a cross, can you make a star? And she's like, we can't, she was laughing, she wasn't aggravated with me, but she's like, I can't take requests. So I'll show them to you sometime, I don't have on tights. But anyway, the point is, I'd have been there a long time had they been guessing and checking and, oh, let's shift it a little bit here and shift it a little bit there. Do y'all see they need to, a new person comes in, just like a new weather pattern comes in, but they need to be able to just crank it out for everybody, or you better find somewhere else to go, all right? Dentist, I don't, you've got this target. If you've ever had a x-ray, have any of y'all ever had an x-ray? And I have had it a couple of times where they left the room and came back in and had to do it again. But I'm a little more impressed if they know right where to do it and I don't have to do that a few times. Anyway, I want to move this graph over. It looks like I'm looking at this graph and it looks like I want to move it over about 1, 2, 3. This one looks like 1, 2, 3, 4. This one up here, it looks like, and when I say 1, 2, 3, 1, 2, 3, 4, they're a unit apart. So each little mark is a fourth of a unit. It really looks like to me I want to slide this over 1 unit. I think the one I did the other day, I wanted to slide it over 2 units. And a whole lot of people, there's not a whole lot of you, but people that contacted me just kept trying to do what I was doing, and then that wasn't working, so then they started fishing around for something else. What I have to see you do is this. Is so you understand how to get the phase shift. Like whatever I put in right there is going to make it shift over 1. I can't put 1 in there, okay? That won't work. So, so what you would do is this. Sorry, I'm trying to get to extend page. This would be true for test or whatever that we run into. So the D part, the phase shift, I know the phase shift always comes from that parentheses. I think on your memo page, is it BX minus C?
Yeah.
Okay. So I know if I set BX minus C equal to 0, that will give me the phase shift. And so if you solve for X, can y'all see real quickly that you'll get C over B every time?
Yeah.
I would add C and divide by B, but we've already decided on B, haven't we?
Yes.
Previously.
5 or 6.
So in that situation, whatever the period is of the graph you're working on, you can go pretty quickly. Don't you want your phase shift to be 1? In my case, I don't know what you want yours to be. I've seen all different things, okay? So if I want my phase shift to be 1, I'm not sure why this won't go. All right, so every phase shift is going to be created by BX minus C. And if you set BX minus C equal to 0, you'll always get X, solve for X. And girls, aren't y'all used to that? That's what tells you how far to move. You want to force that to be 1 or whatever. I needed to move mine over 2 last Thursday. I've seen a few people that this morning, somebody moved it over 1.2 units. to make it lock on where they want to. But it's beautiful. You just set it equal to however far you want to shift your graph back and forth, and it does it right away. Our B is Kate, pi over 6. And so you'll show me this work. I'll save the video. You know, you'll show me this work, turn it in by midnight if you need to change something for full credit. But do you see how you'll look at your data, and I've left you places to show your work on every one of them. So let's go back and put in my phase shift. Now I want minus pi over 6. Now this one, if you actually want to shift it over 1, it kind of makes sense to have, pi over 6 in there, because you know pi over 6 over pi over 6 is 1. But I'm just talking about the mathematics. If I want to shift it over 3/4 of a unit, I can do it so quickly. It's always going to be B over C equals my phase shift if you set your parentheses equal to 0. Okay? And then Nazareth, I think you were like, is it normal to be missing some of the dots? Absolutely. Every now and then somebody just picks a city that just behaves perfectly. But in a discussion I've had with a few people today and over the weekend, you're looking for a best fit curve. I think I emailed that to you also. Where on some other people I said, this is a medical trial and you're trying to model it mathematically to see if the medicine's working or whatever, you'd feel good about that. You'd go, yeah, this is okay. I mean, this fits my data. I would think to myself, do I want to move it a little more to catch these dots, but one, I'll lose more of those that way?
Yeah.
Okay, so you're looking for a best fit curve. There's a really cool way to do it on the calculator that we're going to talk about today.
I'm confused on how you isolate C.
Are you saying that for everyone, C should be pi over 6?
No.
In weather problems.
Okay.
Wait, is it
In weather
Yeah.
problems, because you want the period to be 12.
Yeah.
So the only way to let the period be 12, you would say 2 pi over what would equal 12.
Yeah.
The only answer to that algebraically is pi over 6. And then phase shift, Kate, and this is where my phase shift comes from.
Yeah.
So I taught y'all to set this equal to 0.
Yeah.
And when you solve for x, this is how far you want to move it over. As soon as you solve for x, you've got your PS.
Yeah.
And you want to force it to be whatever is applicable to your situation.
Okay.
You already know B, because you would have just found it.
Yeah, it's 5 or 6.
And then, so if you want to move yours over 5, you'll have 5 pi over 6. If you want to move it over 1.2, you'll have 1.2 times pi over 6. And it'll land right on it as best it can.
And you just multiply 5 or 6 times 1. So
Yeah.
to get the-
You know, I'm sorry, I didn't realize when I picked Jackson, Mississippi, I would only have to move it over 1 unit.
Yeah.
But I might have had to move it over 3/4 of a unit, and I would then say 3/4 times pi over 6. And you find these things that like will always work. Engineers and programmers end up going even faster than this if they're doing the same thing over and over again, which many professionals are really, really good at writing programs for certain things. And so they quickly know they're gonna say the period comes however far they wanna move it, okay? So no guess and check. I've got to be able to, so if you can alter yours, some of you've already sent it to me and you want to change it again, so just say final copy. And I would take a screenshot of this and put it in the back, in the end of the document. So quick questions, Anya?
I don't need to change anything, but for the period, you went deeper into it, so I kind of just wrote that out in pencil, but can I turn it in like this if it's
Yeah,
typed in?
yeah, I've got Julius is in pencil,
Okay.
yeah. Is that what you're gonna, no, cause I have a digital copy of yours,
Yeah.
yeah. I didn't look at
Is
it,
yours
I just
digital
got
or
it.
No, I'll send you another one.
If you wanna
Is
send
your
another one, I
definition-
thought in good conscience I'd wanna go over this and for full
Yeah.
Is your
credit.
entire table?
It's the whole purpose of the
It's
project,
helpful, yeah.
Is your
is that
entire
you
table?
target your
Yeah.
numbers. Nazareth?
I ended up getting to pi over 6 for the phase shift when I redid the showing my birth. But in order to get full credit, would we need to write the logic?
That's what I'm saying.
Yeah.
You've gotta show me that you know what phase shift
Right.
means. Okay? So your phase shift comes from bx minus c, solve for that. Everybody's B on my project I picked. Some of the different projects, different things in life have different periods. everybody's weather is gonna be 12. I don't know of a city that I know of that doesn't complete its cycle every 12 months. I don't know of one that goes up and down and then up and down. That would be really weird, but maybe there is one. Question?
So you're saying the like phase shift number that we're supposed to move it over, like for example 4, instead of the 1, you would put the 4 there,
Right,
and then you would solve it.
yes,
Okay.
yeah. Okay, so, let's move on.
Can I turn this around?
Yeah.
Thank you.
Alright, that should really help you review a lot from the test as far as with sine and cosine graphs, but let's move on. So any questions on your homework? We can go over any questions you have on your homework.
Can we practice graphing?
We're gonna practice graphing, but, I could start with specifics.
I think one of the last two.
What now?
This was all I need. Here, so, okay.
Yeah.
I just.
Are you ready?
Yeah.
Okay.
Can we do 147?
Yeah, can we do
147.
143 and 147?
Are y'all saying 143 and 147?
Yeah, why are you saying it like that?
Was that like a million?
I'm sorry.
134.
You mean 43?
Oh, no, I had a
I
question.
should slow down how they were
Yeah,
saying that.
It's about like the pi.
Can you give it to me in 3 digits, like 1, 2, 4? I'm just kidding, I'm teasing them. So, let me do Mia's question and I'll get to you. Okay, so. What page was it?
342.
Alright, 342.
Yeah, just did.
And first thing I'm gonna do, Mia, is what number?
147.
Alright, 147. Alright, good question. Alright, so, let's fade out this picture. Will you get your reading the numbers?
That's
We're gonna
so
do
brave,
147
your
in
finger.
a minute. 147, Mia? 147?
Yeah.
Okay.
I moved you.
Okay. So, Elena, what is 147?
1/2 cotangent parentheses x minus pi over 2 parentheses close parentheses.
Okay, that's it? No vertical translation. Alright, so, looking here. Okay, okay, so
Oh, great.
wherever your phase shift, phase shift, phase shift, phase shift, phase shift, phase shift. Alright, so the first 5 are CSCs. Sine, cosine, secant, cosecant, cotangent. And the last one is tangent. Do you see where I put my target in the middle? When you get ready to graph sine, if it's positive, go to your phase shift, go immediately to the right, and you would be going up.
Yeah.
If it's cosine, go immediately to the right, and you should have been coming from high if it's positive. If it's secant, these just follow suit. Okay? That makes sense? Because you would have had to do the others. Cotangent, this is your start. Alright, so immediately to the right of your phase shift, you're in the positives. With tangent, here's your phase shift. Immediately to the right, it's positive. So that's why that one goes this way. So I'll be doing that as I work these problems. Alright, so a cotangent graph. Alright, so it doesn't really have an amplitude. It has stretch of 1/2. The period is, be careful, they're really short, pi over 1. Phase shift that we just talked a long time about, set that equal to 0. Sometimes I have to physically, algebraically do it, but this one I can do in my head. It's pi over 2, and vertical shift or vertical translation is 0.
On our test. if we-
This is my starting place, because it's a C, CSC.
If we write amplitude instead of stretch
I won't
by
count
accident,
off, but I probably
Okay.
shouldn't have, because I know you're probably just note to self, okay?
we'll write amp/stretch.
That's fine too.
Okay.
Okay. So now, some of you saw in your quiz something that I had been belaboring these points a lot, that you need to think about the scale that you're drawing these at. If you didn't mark it off correctly and you're trying to count backwards, you might have to redraw it, okay? So you might want to think ahead. You've heard me talk about how much is my count compared to my starting place or whatever. I'm sorry, I forgot to get count. What I'm going to count by is pi over 4. Okay? Always add that to that, always. Count to phase shift. And by the way, these marks are gonna be half as big as these marks. So I'm gonna put pi over 2 right here, just because I wanted to. And I'm gonna count out, cotangent counts out 1, 2, 3, 4. I'm gonna make this 2 pi over 4 and add pi over 4. For 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. An oriented board is a beautiful thing. That's the first time I've been able to do that so far. Get to the end of cotangent, you have a asymptote and an asymptote. But this was your target at pi over 2, 0. Okay? It's a positive cotangent graph, so immediately to the right, I go up 1/2. That means this one's 0, and this one's down 1/2. And it's sort of flattened out a little bit there because it doesn't have a very big stretch. Now to graph another period, I'm going to count backwards. If I say 2 pi over 4 minus pi over 4, that gives me 1 pi over 4, which fits in really well. If it didn't, you can't just squeeze it in or forget where it should be, okay? It matters. So this will go 1, 2, 3, 4, asymptote, and it follows suit like this. The period's pi. You always divide it into 4 equal parts. Period is pi.
How did you get the period to be pi?
Tan and cotans, period's pi over.
Oh, okay, thank you.
They're the little people,
Alright,
okay?
thank you.
Which is probably
If
insensitive
it's
of me.
positive, it always goes up on the left first.
The way I always remember it is wherever my target is.
Yeah.
When I go to the immediately the right, if it's positive, I better be up. And so this was my phase shift. So immediately to the right, I went
got
up
it, okay.
and put my first dot.
Makes
Wait,
sense.
can you say again, what is the period for cotangent, tangent? Almost.
Pi over. Not always pi, it's pi over b instead of 2 pi over b.
Okay, thank you.
Remember, I've tried to get y'all to remember it this way with my fingers. Okay? Sine, cosine, secant, and cosecant, they're all longer, 2 pi over b. These are pi over b.
Okay.
They're little curvy.
Thank you.
Okay, so to speed along, Anya, what number are you okay, Mia? Okay.
143.
All right, thank you. 143. All right, so, that's pretty fun. Just a minute, I gotta lighten this picture so I can write it.
Are we gonna have a memo quiz incorporated to this?
No,
just like the
no,
last
no,
one?
no,
This one's
no.
just graphing
Right.
stuff?
And I'll talk about that just a minute.
Okay.
I just put a bunch.
Library.
Yeah, I think so. It's not my best one, but I don't know.
Okay, Elena.
Oh, yes.
Okay.
1/4 tan, parentheses, x minus pi over 2.
Okay, so the stretch, the fake amplitude is 1/4. The period is little tangent, so it's pi over 1. The count is pi over 4. And the phase shift is pi over 2. I can do it in my head. And the vertical translation, there is none. Right, so my target is a lot like the same count as the last one, so I can go a little faster. Now I have to be really careful with tangent because I gotta have room to go out to and back to and land in the right place. The two that I'm doing first today, they just land right on zeros sometimes. That doesn't have to happen. You could just skip all the way over it to your next point. All right, so here's my target. Now with tangent, I'm gonna count out pi over 4, which is half as big as the pi over 2's. I'm gonna count out 1, 2, 3, 4. When I go 1, 2, asymptote, back to asymptote. The stretch is really brought in at 1/4 and negative 1/4. So here I am at my target. So I'm immediately to the right. If you're doing a positive graph, your first dot should be a positive 1/4. Then negative 1/4, and you have the right picture as long as you're always going back to your phase shift. And then count out 1, 2, 3, 4 more. 0, 1/4, negative 1/4, and so on. All right, Anya?
Yes.
Okay. Other questions on that, on homework, anything on homework? Thanks, Alina. Okay,
Actually, no, this isn't relevant to the homework.
okay, let's finish the homework and then, Alex, you have a question?
Well, it's sort of, so when it's in phase shift, it's like x minus pi or x plus pi, and it seems to have some sort of like effect on the entire movement of the graph. Like when it's x minus pi in the phase shift,
It'll go to the right.
it'll like inverse, not inverse.
Oh, no, this is what it's doing. I mean, if you're looking at it incorrectly, you could think that. But if I take this whole entire graph and if I see what color this graph is. All right, so there's red and black. Let me turn off the red. See the black? Red and black. If I change this to plus, all right, before I do it, I'm going to say what it's going to do. It's going to, changing it to plus is going to shift it backwards somewhere. All right, so when I go plus and turn it back on, do you see it just shifted it back actually 1 unit? Because if I set that equal to 0, I'll get a -1. So putting in phase shift, like what it did to this was a graph with no phase shift. So if you put here's something with an X in anything, Alex, it could be this. It could be X squared. It could be X squared. And girls, listen, this is for everybody. If I go X plus 3 squared, it's going to shift. I'm going to turn off the purple, everybody. Not just Alex. Look, I'm turning off the purple. When I turned the purple on, it took that same picture and moved it back 3. So your phase shift's just sliding it left and right.
Yeah.
To get it in phase or in sync. It may appear to you that it flipped it over or something, but it's probably just because it dragged the high over something. I mean, for instance, like this can look misleading if I do cosine x, cosine x. Oh, that's weird. That's interesting. And cosine x minus pi over 2.
That was so funny. That was like straight out of the movie. It was hilarious.
All guys like I would not pick Peter because he's gonna be like, what? Necessary.
Hang on just a minute. Let me finish answering her.
I think I get it.
I want to go in and finish it since I've gone this far. But it's not cooperating with me and I don't know why. I don't know why that keeps popping up.
Katie follows her on Instagram and was like looking through stories and stuff, and then her story came up, and then it just hit, and then she sent a screenshot. And she was like, "Is this for friend? Did you have that?" It's like,
This is weird. Maybe I got it now.
Undo. Awesome.
She's really great. One person or like we're finding we're making one work. She was one of her videos. She was like,
Practicing how to get money, practicing how to follow track.
Where'd 0 go? Oh, here it is. So anyway, all different things in here. It can look like the red one is actually a sine graph.
Yeah.
But if you see my equation, it's a cosine graph that I shifted. I shifted my cosine graph. My black graph, I shifted it to the right pi over 2. You can easily see it's a cosine graph.
Yeah.
So in fact, somebody could walk in here and go, I don't want to do all of that. I'm just going to write that as this. And do you see the black and the blue and the red are the exact same equation?
Yeah.
Okay, but phase shift's just going to move it left or right. It's not going to do anything else. Okay? All right. Other questions?
Yeah, for the cotangent/tangent one,
Uh-huh.
so it was number 147, it was the cotangent. Like, you said that you have to do 2 of them.
Mhm.
So how would you space them out between them? I don't know how to.
Okay, I think I just did it. I think I did a cotan and a tan
Was
one.
I here?
Just now I did? Oh, okay, maybe you missed it.
Yeah,
Like
no, 'cause
here?
that's when I came back and I saw it. I just needed to
Okay,
space it.
so I had done this one. I had gone.
Uh-huh.
I'd already thought about how big pi over 4 is in relationship to pi over 2.
Yeah.
And I went 1, 2, 3, 4.
So you just make another.
Asymptote graph, and then I went 1, 2, 3, 4 of the same size.
Thank you.
And if you look back a slide later in the video, you can see me do the cotan one,
Okay.
Okay. or the tan one, whichever one. I think it was cotan. Okay, other homework questions. All right, want to make sure I get to Alina.
Oh, Marshallina's is
Oh, it's on the next
so
slide.
cute.
Somebody
Oh,
said Miss
so
Lazari.
cute.
I'm so hot in this cute sweater. Question?
Yes.
Sweating in my
When
cute
it
sweater.
says graph. Oh, I thought
I could
so.
take it off.
Yeah, I was like, I'm so hot in my cute. I was like,
Just take it off, I guess. Okay.
when it says graph through 2 periods, that's how many spaces? I was messing that up.
Graph for 2 periods, just graph 1,
Why
finish it off, and then count out 4 more.
So that's like, for like the sign, it goes, that's 1 period,
Uh-huh.
and then finishing it.
Yeah.
Okay.
2 periods of a sine wave would be 4 bumps.
Okay.
Okay?
4 on the top, 4 on the bottom.
No.
Just 4 in total.
A sine wave goes up and down.
Yeah.
There's a bump at the top and a bump at the bottom.
Yeah.
You came back to where you started from.
Yeah.
And started. That would be 2.
And with codes, it's just,
Well, you start high.
yeah.
High, middle, low. Go high, middle, low, middle, high.
Yeah.
That's 1.
Yeah.
Then go middle, low, high. Then just do it again.
Okay.
I don't know why I'm doing it in the air. I could do it here. We're gonna go. Here we'll go from our eyes. You go high, middle, low, middle, high. Okay. And then you would do it again. Middle, low, middle, high.
Okay.
Okay. All right.
The nose.
Other homework questions. These are great. You really, really thought about your homework. I love that. And you got your project done. Make sure it's all, I get your final, this is what I want you to grade project by midnight if you haven't already given me a paper version. 12:01 will be a late grade. Okay, now, so let's go to, here, we'll go to Bryn.
That picture is the first image. First image. I love that picture. It's
Okay,
so funny.
so.
It looks like you only have 1 eyebrow.
I literally, I just.
I think it's 'cause you're kind of doing the whole, like-
funny.
I think it's because it's cursed.
Okay, now, look
She's like really gone in your
for
face.
Oh my gosh, she's
this
a ghost.
sheet. Look for this. You did it for homework a long time ago when we did the tie, before you did the weather. I think we did the weather also.
Oh, we did.
Yeah.
1 and 2, we did the weather.
Yes.
All right, let's go to the 3rd page, the depth of the water. Is that your 3rd page?
Yes.
Yeah.
Okay. All right, so the depth of the water at a generating station can be represented by the following graph. And this is this is real life, like where I said the other day, and y'all kind of, giggled at it, that your people don't go into their job and somebody hands them a worksheet and says, here, graph these. They're probably looking at data like you did with your weather, and they're having to model it, because if they can't model it mathematically, they can't study it. Oh, you're good, yeah, thanks. Okay? So we're looking at data of the depth of the water at a generating station, whatever that means. Find a possible equation for this graph. I'm just gonna do it if that's okay. I think this looks like a sine graph that's been shifted up 4. I think that's just the easiest thing. Maybe I can get away without a phase shift, okay? So I'm gonna use a positive sine wave. I'm gonna leave myself some room for all my different little things. I'm gonna try to do without a phase shift, okay? All right, so a possible equation for this graph. It looks like the midline, the middle's not 4. I'm gonna need a phase shift, I think. So if you have, the low is 2 and the high is 8 divided by 2, and so what's the midline? I believe it's 5.
Oh,
Okay, so 5, and so the midline's right here at 5. So it really, I'm gonna have to shift it over to start right here at 5. The amplitude is going up 3 and down 3. 5 plus 3 is 8, 5 minus 3 is 2.
Crystal Sarah,
Uh-huh.
do we have to label it like the high being 8 and like the low being 2?
I don't know what you mean, the high is 8 and the low is 2.
Okay.
Like there's not.
Because I don't know, I labeled it as like 2, like 1, 2, 3, 4, 5, 6. So my high was,
Oh, do you not
5.
have numbers out to the side? 2, 4, 6, 8?
oh no, I had to label mine. That's why.
Okay, do y'all have numbers out to the side of yours, 2, 4, 6, 8?
Yeah.
Yeah.
It's weird. You
Always-
emailed me mine, so it's.
Always download it before you print it.
Yeah,
It appears different.
I think I did. I downloaded it.
So that's a good question. It would have been different with
Alright,
yours. Okay, you could have made up your own numbers if I don't put
I
some.
tried to help.
And I'll put numbers.
I'd give you
Alright.
another one, but I don't
Okay,
think it's
girls,
good
we
to
need
have
to move
that
on.
many.
This one's gonna bring up something really good. Because it actually hits 5, the middle over here somewhere. All right, what's the period? Sorry.
Anya.
What's the period of the graph?
I swear to God, I will be sick tomorrow between these two.
Actually, no, I'm not contagious. I'm not contagious.
China has
Wait,
this
what is
like
that video?
Go get your vaccination.
I saw
It's
that.
12. It was 12.
I saw
Okay,
that.
girls, the way I can know for sure the period is 12, I don't always look from middle to middle. Sometimes it's easier, Dakota, y'all listen up. Sometimes it's easier to look from top to top or bottom to bottom. Sometimes I was having a hard time looking at the middle just then. But you see it hits a peak at 4 and it hits this other peak at 16. So it's definitely 12. If it's 12, I would say 2 pi over what would give me 12. We have 12 once again. We all know that's pi over 6 right now. So this is pi over 6. All right, now I don't quite have the equation for this graph because I wrote it as a sine wave that actually picks up at 5. Where do you think this one hits 5? Draw a line through between 4 and 6 on your paper if you found it. Draw a line through at 4 and 6. If I draw a line through at 4 and 6, it looks like my sine wave picks up at 5, about where? Those of you that have a sheet of paper. By the way, this is 4, okay? And so 2 is right here. It looks like to me about 1 hour in. Do y'all see what I'm doing? It looks like it picked, I want to shift everything over. Right now I've written something that looks like this. My data would be lining up in here a little bit off. So I want to shift everything over. In fact, my peak right now looks like it would be at 3. I want to shift it over to my peak being at 4. So I'm going to shift it over 1 unit. So I want to know what to put here. All right, so I do the bx minus c equals 0. My phase shift is c over b. We already know b. We already found it. It's pi over 6. So that gives me 6 pi. Sorry. If I multiply by the reciprocal, that gives me 6c over pi. I want to force that to be 1. If you solve for c, that'll give you pi over 6. And so now if I put that in Desmos, let's see if we get the graph for those of you that found your paper. So let me get rid of all of these. All right, so what do I have? Y equals, what did I have on the other page? 5 plus 3 sine pi over 6 x, sorry, pi over 6 x. If I just left it like that, this graph's peak occurs at 3. Those of you that have a sheet of paper in front of you, did something happen that was weird?
Yes. She was doing the TikTok dance, it was just really funny.
What just
She was
happened?
No, she just did a little dance, that was silly.
So anyway, this graph's peak occurs at 3. Those of you that have a sheet of paper to look at, like Anya and Mia and Nazareth and Kate and you sort of, because you don't have numbers. Does our peak occur at 4? Our first peak occurs at 4, and our other peak occurs at 16, whereas this one's occurring at 15. So I'm going to shift it all over 1. So I calculated to make that happen, I would put in minus pi over 6. Having a hard time getting pi in there, sorry. All right, and now those of you that have a sheet, it looks just like it. Okay, my peak is at 4. If I move down, my peak is at 16. My valley is right at 10. So is theirs. It's exactly like the one on the sheet. I've modeled the data. Now it says calculate the depth of the water at 9:30. So this is time and hours, it says on our sheet, if you had one. So it's 4 hours after midnight. So when would 9:30 a.m. be? It'd be at 9.5? 9:30 a.m., wouldn't that be 9.5?
Yes.
Okay. So at 9.5, I could estimate it right there. If you had a calculator, you could like draw a line through it like you've seen me do. Having trouble getting it to 9.5. But it would be about 2.0 something. I think it's actually, it's 2.102 at 9:30, okay? So you got something close to that. So anyway, there's ways to do that on your calculator that I haven't really gone over a whole lot that I would go over more. I think one time I've done it with you where it's like calc intersect. And then at what time does the depth of the water first reach 4.3? So if I had a calculator, this is what I would do. I'm not going to pull it up right now. I do have a calculator, but in the interest of time, I'm not going to pull it up right now. I'm going to show you what you would do on your TI, which is coming. Maybe a bonus on the test or something, okay? Do you see I want to see with my eyes when the depth of the water first reaches 4.3? So I actually visually put in y equals 4.3. So I can see the first time. Now Desmos, we can kind of cheat and put this in and we can actually find it. 4.3, there we go, okay? Now how can I figure that out? This is in hours.
So it'd be 12:55.
No, that's
Oh, that's
0.55 of an hour, so it'd be 30-something minutes. So you would say 0.55, you would need to multiply that out of 60.
got it.
You've got to change it. I'll write it down for you, okay? Well, after this test, we'll look more at our calculator skills where you would type this into Y1, you would type this into Y2, and a lot of y'all, if not everybody, has had the experience of going second calc intersect and finding it, okay? All right, I'll take a question just a second, but let me finish this. I got 0.55. All right, so that's of an hour. So if I have, right now is 0.55 out of 100, I need to know how much that is out of 60 minutes. Do you see the difference? So I'm just doing a ratio. And then, so if I multiply this and cross multiply, I'll find out how many that is. I don't have my calculator out, but it would say however many minutes. Do you have a calculator?
Yeah.
Okay. 0.55
Times 60.
times 60.
Over 3,000. And just divide by
divided by.
Oh, I'm sorry, I shouldn't have 0.55 over 100. I should have 55 over 100, sorry.
Okay.
So that'll make sense. It was 0.55, which is 55 over 100. 0.55 is 55 over 100. So 55 times 60 divided by 100.
So 1233.
So you got 33?
Yeah.
Okay, so it'd be 1233 since midnight. So I was really right in saying this. You could just say 0.55. If you ever want to change it from decimal to minutes, you could just multiply by 60. Every now and then I want to talk about just that real life stuff. Again, in the interest of time, we'll leave the Ferris wheel for now. That's a fun problem. Let me give you your review. It's maybe a bit overwhelming, but pick and choose what it is you want to study. If you can do all of this and the 3 application problems I went over, excluding the Ferris wheel, you'll be fine. It's a lot of questions, and some of it's multiple choice, and then I think all of the answers are right, I hope. If you find one confusing, let me know. What I suggest, and we'll leave right on time, I suggest you try to graph it, like this one's 5 sine x, before you even look at the multiple choice. I think that's in your best interest. Just try to graph it and then match it. But you can kind of go with instinct if you want to. I just haven't made out the test yet though, so there might not be any matching. So kind of just feel like you're going to come in and graph and be glad there is matching. Maybe. Sometimes matching can be confusing. All right, so anyway, when you get one, you can run away. And please see me. This is like
Thank you.
overkill review, but I had it in my computer, so I thought I'd give it to you. Okay. Mary Mountain has always like big packets.
I love it.
Packets. Makes you feel like you've done something.
Oh, wow.
Yeah.
It's really good.